Today we're talking about the grid dynamic flow layout, which is the dynamic flow layout you get automatically whenever you create a new WPF application. And the grid can be like an XY table, just like the XHTML tables, or not just like, but very similar to the HTML table that I'll probably discuss in a comparison video in the next video. And as such, they're made up of row and column definitions, and these are defined as property elements: grid.row definitions and grid.column definitions. And as you notice by the S on the property element, these are also complex properties that are a collection syntax, which means the main name has an S, and then the object elements that make up the complex property is the name without the S. In other words, row definition or column definition. So within the row definition, grid.row definitions, you're going to have multiple row definition object elements, and the primary attribute for row definition is height, as you might realize when you think about it, since they're going horizontally. And the primary attribute for column definition is width, since they're going vertically. And there's three ways of specifying the height and width. You can specify them as absolute values, sort of with quotes around absolute, like 50 pixels, but then if you do that, you'll notice it'll say 50 and an asterisk, and that's because the asterisk is a special character that means proportional. That basically means that if one column is twice as big as another column, because it's 50 pixels and the other one's 100 pixels, if you expand that out by expanding the window, those proportions remain the same. So one will be twice as big even though they're different pixel values. And then the other way you can specify it is auto, which is the keyword auto, and that just says make the cell, which makes up of a cell is made up of an intersection of a row and a column. Make the cell as big as it needs to be to fit the content, whatever the child elements are inside it. So that's auto. And then proportional basically says make all the cells the same size, like a chessboard or a checkerboard or a tic-tac-toe board, I saw in one video. So you can define these property elements by just typing them in Xaml within the grid tags. But a much cooler way of doing it is to click on the borders, as I'll demo in a second. Basically, when you get this bare bones layout, click on the grid to select the grid, and then move up to the column or the border at the top, and you'll notice a line appears which could define a column. You can move it back and forth, and just click on the column, and that column appears, and the grid.column definitions gets defined in the Xaml, and you have two column definitions within it because you defined two columns, the one on the left and the one on the right. And you can come up and define a second column, and that adds another column definition. And then you can do the same thing for the rows. Just click on the left border and define a row, and that creates the grid row definitions with two grid row definition object elements and heights. And you notice these are all proportional because initially you're getting an absolute pixel value by clicking. And click on a second one, and you get another row definition. So we have a basically 9-cell table, and we want these to be equal size. So instead of the absolute height and width definition, we want to just make these proportional. So we can do this by eliminating the absolute values and just leaving the asterisk that says these are proportional. And you notice if we look up here, now all these cells are exactly the same size. And if we expand it out, they'll remain the same size. Depending on how we expand it, they may become different shapes, but they'll always be proportional to one another. Well, in this use of the grid with the proportional height and width, I have a picture that my son actually took at a anime expo. I have no idea who this cosplay guy is supposed to be. He looks like Mr. Happy Tooth to me. But I'm no doubt offending a lot of anime fans when I say that. I think they call anime fans otakus. But if we go down and look at the Xaml for this, basically for each cell I have an image statement. So I have 9 image object elements. And these have a horizontal line of stretch and a vertical line of stretch. And then I have a stretch attribute that is uniform to fill. And basically what that means is you maintain the aspect ratio, so the picture always looks good. Although parts of the picture are going to get cut off, or parts of it are going to be displayed based on how you stretch the window out and how close the window comes to resemble the shape of the original picture. So basically uniform to fill is really useful if you want the picture to look like the original picture while it remains within the cell. And for each of these, you notice I have attached properties of grid.column, and for instance this one is grid.column equals 1, which would be the middle column, because the first column's 0, second column's 1, and the third column's 2. And then I have grid.row equals 2, for instance here, which would be the last row. So grid.column equals 1 and grid.row equals 2 would be this guy right here. And if we compile and run this, you notice the pictures look just like the original pictures, although the original picture is quite a bit bigger. It's been shrunk down to fit in this cell. But if you expand this entirely vertically, more of the picture appears because the picture is actually shaped in a much more vertical manner than the original. And if you expand it horizontally, parts of the picture starts to disappear in order to maintain the aspect ratio. So it gets truncated out on the bottom. And then if you click on the full screen, boom, instant screensaver. Pretty cool, eh? Well, I hope you enjoyed this video and learned a lot, and I'd appreciate it if you subscribe.